is distributed to the 5. So this becomes 5 squared. But wait, how does it become 5 squared? Well, what's the rule when you have an exponent outside the brackets? We multiply with the exponent inside the bracket. But I don't see an exponent on the 5. And well, you're right, you don't see one. That's because it's invisible. There's an invisible 1 there. So we don't write 5 to the power of 1 because everyone knows 5 to the power of 1 is 5. But there is an exponent value of 1 there. So don't forget that. And now, what is 1 times 2? Well, 1 times 2 is just 2, so it's 5 squared. The x value also gets a multiplication factor of 2, but not the x term, but the exponent. So what's a half times 2? Half times 2 is just 2 over 2. Then we have a multiplication sign. And then we have 4x to the power of negative 1 over 2. And we can simplify the bracket first before we move on. 5 squared is 25. And x to the power of 2 over 2 is just x. And now we are multiplying this term with this term here. And we know the exponent on x is just 1. So 25 times 4 is 100. And x times x, well, you have to look at the exponents now. 1 and negative 1 over 2. Remember, if I'm multiplying two similar base values or base terms, I need to add the exponent. So what's 1 plus negative a half? 1 plus negative half. Well, that's just 100. X to the power of a half. That's the answer. So this is an example of all exponent laws. So hopefully that's helping everyone. Let me just take a look at that calendar again. Yeah, okay. Yeah, all right. Okay, so yeah, exponent laws sounds good. Actually, just one second. Adding and subtracting. What about multiplying, dividing? Okay. Went straight to the hard stuff, eh? All right. Okay, next lesson. So just so you know, this is all under the unit rational expressions. So lessons 1, 2, 3, 4. I would suggest watching each video, doing each lesson section. There's no video here. Videos, 3 videos here, and another video there. So let's do this one here now. Yeah. Okay, we gotta do this. Oh man, it's too much stuff here. But yeah, let's teach the first part. All right, lesson 1 for rational expressions. The previous lesson was exponent laws, which is very useful as well. But now I'm going to do example 1. All right, here we have example 1. State the restrictions for the following rational expressions. What are restrictions? Restrictions are values that x cannot be, otherwise it will break the question. What do I mean by that? Well, when we're dividing two values, there is a rule when it comes to division that we cannot divide by something. Everyone should know this. We cannot divide by 0. If you divide by 0, you will get an error. So that is kind of like the rule that we're breaking if x is some value. So what value does x have to be for this equation to become dividing by 0? Well, it's very simple. You just take a look at the denominator. And you see the denominator is x minus 2. If I plugged in the 0 into x, that would be 0 minus 2. And if you simplify 0 minus 2, well, that's just negative 2. So that's not an example of dividing by 2. Because this is an example of dividing by negative 2. If I plug the 0 on the top, well, that's just 0 plus 2, that's just 2. So if I substitute 0 into this equation, or rather I should say relation, it just becomes 2 over negative 2, which is negative 1. That doesn't break the relation or equation or question. We're not dividing by 0. So what value will give us that result of dividing by 0? Okay, so if you haven't figured it out, if I substitute a value of 2 into the equation, so this becomes 2 plus 2 and 2 minus 2, and the top becomes 4, the bottom becomes 0, and this is an example of dividing by 0. We cannot do that. So all we have to do is, when we say state restrictions, we just say x cannot equal 2. That's how you state restrictions. All right, very simple, very straightforward. A few things that you should know. When we're stating restrictions, you only take a look at the denominator. We do not care about the numerator, because numerator is allowed to be 0. You're allowed to have a question that says 0 divided by 4. That is allowed. You can do this in your calculator. Try this right now. Get your calculator, punch in 0, hit divide sign, hit 4, hit the equal sign. You'll get a value. You'll get 0. But if you were to do 4 divided by 0, if you try that on your calculator, you get an error. So 0 allowed for numerator, not allowed for denominator. So only take a look at the denominator when we're stating restrictions. All right, another way to do state restrictions is when you have a nice denominator that's factored like this. This is very helpful, because all you need to do now is take a look at each individual factor and make mini equations and sub them equal to 0. So take a look at each bracket, x minus 3, and make it equal to 0. X plus 4, and make it equal to 0. And all you need to do is now solve for these simple, basic grade 9 equations. So, the negative 3 goes over, so x is equal to 3, and x is equal to negative 4. What does this mean? That means a value of 3 and a value of negative 4 will make this equation, or this relation, dividing by 0. And we don't want dividing by 0. So our restrictions are just going to be x cannot equal 3 and cannot equal negative 4. And I made a mistake here. Not really a big mistake, but you should probably follow proper order. And that's just writing the smallest number at first and then increasing thereafter. Okay, so this restrictions for example B, we actually have 2 numbers. We have 2 restrictions. What about C? What are the restrictions for C? 5 over x plus 3. Well, we don't care about the 5. It doesn't really affect us. Just like here in the x plus 2, we don't really care about the numerator. But we do care about the denominator. And something that students need to know is this x that's all by itself is technically in a bracket because it's multiplying, right? It is multiplying, so it is in a bracket. We just don't have to write it. We don't show it, but they're there. Because 2 brackets like that state multiplication. So why is that important? Because a lot of students forget to write 2 equations here. X is equal to 0 and x plus 3 is equal to 0. And obviously this just becomes x negative 3. And since we're talking about restrictions, it's x cannot equal 0 and x cannot equal negative 3. So these are the restrictions here. So yeah, so those are restrictions, very straightforward. X cannot equal those values. Now remember, if you want a more in-depth lesson about these things, watch the video that is attached to each different lesson. All right, so yes, you can see the answers here. All right, let's do this one.